Hello users. Today I want to show you some of the cool features that we now have in ERA that we call time-based data. Uh, First thing I need to point out is how we arrange and manipulate time-based data. Time-based data is stored external to our well designs. So if I was working on a project here with multiple well designs, the time data doesn't actually live within this well design itself. Where the time data is stored is external, and we kind of give a nod to that with this icon off to the right. And if I were to click on time data, it would pull up our main process for viewing that data. But this is the main portal where you import and store the time data. You can also access it from the well design itself, but I think it's important to recognize that where it resides and where it exists is external to the well design. And by doing that, if we have, say, 3 months of time data for a particular well, it can be stored outboard of the well designs so that if you have multiple well designs, if you start copying and pasting well designs, you're not actually copying and pasting those 3 months of time data every time that you make a copy of your well design to try different scenarios. So I think first and foremost, that's important to make note of. The other thing to point out is that time data is really only applicable to executed well designs. And this was a well design that I'd already executed by right-clicking on a planning file. And on a planning file, you'll see an option that comes up that says execute. I've already done that. And you'll notice when I double click on the project, you can see that I've got two hole sections, 8 3/4 hole run 1 and run 2, that are already executed. I don't have data within these particular sub-ops. You'll notice that there's no depth-based off-bottom data, and there's no depth-based on-bottom data, and I haven't brought any time yet either, so these tables are both empty. The only data that I have put in is mud data down here on the bottom. But the goal of time data is to be able to port this information that's in a time domain and convert it to a depth domain without you having to manually enter it into these tables like we traditionally used to do. Once you're within the well design, you can access and import your time data with this tab over to the left. And if I click on that tab, you'll see that it pulls up a screen near identical to the one that we had looked at when we clicked the tab on the right of the project desktop. And from here, I can also start bringing in information. And how you would do that is in your upper right-hand corner, you'd hit this plus button and create a name for your new data set. And the name should have something to do with the well that it goes with. So let's just say that we call this data for well number 1. Okay. And then when we click on data in the right-hand corner, that's where you can import the information. Now, ERA is set up to be able to import LAS files and CSV files, or you can just copy and paste from Excel straight into this table. However, for really large data sets, my recommendation would be to use the importing feature. And I've gotten in the habit of doing that anyway. It does tend to be less time consuming than copy and paste. But what I would do is just find the data file that I want to bring in. So this CSV file, time data 1, I had originally acquired from MD Totco, from their well data drilling recorder system. And once ERA's had the chance to read all the channels, you can decide individually which channels you want to bring in, or you could just bring them all in and then have a look and make sure that that's actually what you want. And what this initial step will do is make sure what ERA has to do, let me back up a minute, is interpret the header mnemonics from the file and make sure that that's consistent with ERA's mnemonics. And so if you scroll down the list here, you just want to double check and make sure that when the data file has a channel, let's say called hook loads, that ERA correctly interprets that as meaning hook loads, not say pump pressure or weight on bed or something of that nature. Most of the time, with say a Payson or MD Totco data file, ERA does a great job of interpreting the mnemonics, but let's say that you're getting data from a different source where we haven't built up a library of mnemonics yet, you may have to do some manual allocation of those channels so that they're pointing in the right places. If I just scroll on down, it looks like most of the channels are read correctly. There's a couple here, block velocity, block acceleration. I don't actually need those because we calculate those within ERA itself, so not all that important. Once I've confirmed that all the channels that I want are coming in, I just click OK. And here I'll tell you what it's doing. It's thinking here because I've got several days worth of data. And once the data is brought in, you could manually delete stuff that doesn't look right, or you can just say, I'll deal with that later and close the screen. And you'll see the data in what we call the segregation view. So segregation is how we're going to decide during which parts of time we're doing different things on the rig. Two different views, what we call segregation and rig state filter. First step, segregation. What we're doing in segregation is identifying subops within this time series. And if I hit the plus button, I immediately create a segregation of the available time data. Yellow is the current, identifies the current stretch of time that we're going to allocate to a particular subop. And the first thing that we're doing in this data file is drilling. You can see that from the ROP channel here. And of course, the depth, we're getting progressively deeper as time goes on. So we're drilling during that period of time. There's really only three different types of subops: drilling, tripping in, or tripping out. And I'm going to select drilling here. And then what you do is graphically grab this bar and drag it to the period of time where drilling has ceased. So right about here for run 1, that's the end of drilling for run number 1. And then the next step in the workflow is to come over here to your executed subop column, click on that, and then point it to the correct place. And I've got an executed subop that I call 8 3/4 hole run 1 exe drill. If I click on that, now that data will get moved into that depth-based data, and the data will appear on the plots. And we'll get to that here in a minute. Next thing that we do, hit plus button again, and the next step in this time sequence is tripping out. And one of the little quirks with the area at the moment, we're going to fix this, but one of the quirks is it's really best to do your segregation in sequential order. And what I mean by that is don't identify the drilling of the last run and then go back to the very first run's trip in and try to identify that. ERA really expects this to be in sequential order, and it just works a lot smoother if you stick to the sequential order. If you get out of order, that's okay. Just delete the row, and it's real easy to just go back and start over again. Not the end of the world. So, sorry, not tripping in, tripping out is the next thing that we're going to do. And if you didn't notice it, there is a vertical bar on the y-axis over here that you can't see. We're also going to change that in subsequent versions. But just know that that edge is there, and that's how we delineate the beginning and end of each time sequence. Next thing we're going to do after tripping out is tripping in with the next run. So I pick trip in. And trip in doesn't quite start here at the end of trip out. It starts about here. And I'm done tripping in when I get to about here. I'll just say that's run number 2, trip in. And then add one more subop, which is drilling run number 2. And there we go, run number 2 drilling. So this was a pretty simple case. We just had 2 drilling assemblies, 1 trip out, 1 trip in. Obviously for a longer well, a more complicated well where you have lots of BHA trips, this is a little bit more time-consuming process, but pretty straightforward. I would say that this is the hardest part of dealing with time-based data, but once you've got that down, you're off to the races. A little bit about navigation. So this arrow button here on the right, if you click on that, it will expand the view so that you can see the entire time scale in full screen. And the other thing about navigation is that you can hold down on the control key on your keyboard, and using your mouse scroll wheel, wherever your mouse is pointed, it will zoom you in to that period of time. And as you get closer, the resolution of the data gets better and better. And if you hold on control, you can zoom out as well. Pretty easy. And you can also use this scroll bar at the bottom. Grabbing the edges of the scroll bar, you can zoom in or out that way. And the other thing that you can do to manipulate your view is just double click anywhere and it will pull up all the channels that you could display. By default, we display depth, hook load, block height, and ROP, but you could show any number of channels. You can also shut off the auto scale and set your own scales if negative 50 foot per hour makes no sense in this example. You can change that. You can also change the colors. Right now, what we're coloring is the bins. I haven't talked about bins yet. I will in just a second, but we're shading the categories that we've broken this data down into. You can also color the channels themselves. And there's a little radio button here where you can flip over to coloring channels versus coloring bins. So you've got that flexibility depending on how you want to present things. You could also view the data here with time on the y-axis rather than time on the x-axis. Just kind of a matter of personal preference. And you can also turn off that sub-op shading that we had. And you can also turn off the lines that define the beginning and end points, if that makes for a cleaner presentation. So just some nice handy features there. Also, you'll see copy to clipboard in the bottom right-hand corner. If you click that button, an image will be copied to your clipboard, which you can then paste into PowerPoint or Excel or Word. One other little thing to note, if you right-click anywhere on the plot, a vertical blue line will appear, and there will be blue boxes that go along with the line that call out what the value is on each one of these channels that you're displaying. And as you move this line, the data will be updated based on wherever the line is currently located. So that's a handy little feature. To get rid of it, up here at the top, you see a checkbox here called Time Reference, and you can just turn that time reference line on or off with the checkbox. Okay, so that's segregation. The next step of the process is to move on over here to rig state filters. And rig state filters is a little bit different view. We show a few different channels by default. You can turn those on and off again just by double clicking anywhere on the plot. But what we're trying to do in this screen is separate the periods of time where we're drilling versus picking up or slacking off or rotating off bottom, because we have to define those periods of time in order to put the data in the correct boxes when we overlay on top of, say, our hook load roadmap or our torque roadmap. And how that works is in this rig state filters sub-dialog. And by default, we've got a drill, a trip in, and a trip out set of rules. And what these rules do is define which categories we're going to move data into. And I think for a moment, we're just going to switch over to PowerPoint because I believe it'll make a little bit more sense graphically if we think of it this way. When data first comes into ERA, we put it in a bin or a category that we call undefined. That means we haven't put it into any special classification. Just every bit of time that you've imported, we just call undefined. And once we run it through a set of filtering rules, I'll get to what those filter rules look like in a minute, that undefined data now gets separated into different bins. We have a bin called slack off. We have a bin called pickup. We have a bin called rotating off bottom. We also still have a bin called undefined. But depending on how those rules work out, you're going to break that data down into smaller buckets. The data doesn't get deleted. It doesn't get removed. It just gets categorized into different buckets, kind of like how we categorize people sometimes. The other thing that we sometimes do, and this will make more sense as I walk through the rule sets, is you may break apart undefined to put the data into certain bins, but you also may want to clean things up and say, well, you know what? Not everything that I put into that pickup bin is actually when the rig was picking up. I want to pull some data out of pickup and put it back in undefined because it doesn't really belong in pickup anymore. That's really the basic logic that we go through in this rig state filter process. Now, to put a little more meat on the bone, so to speak, if I was to click on the drill binning rule, you can see what I mean now with that graphical representation. A source bin, what that means is, where is the data coming from? I'm bringing data out of the undefined category, and I'm going to put it into the connection category, meaning at this period of time on the rig, I'm making a connection. I'm not picking up, slacking off, drilling. And the thing that I'm going to use to make that determination, how do I decide whether or not it's a connection or I'm doing something else, is by looking at the slip status channel. Now, for PASON data, the slip status channel identifies connection time as just a binary value, either 2 or 1. 1 means that we're out of the slips, 2 means that we're in the slips. So the kind of Boolean logic is, if I read in this in slips channel a value that is greater than 1, then that must mean that it's a connection, because that's just how what Tutko's nomenclature means. And the way they do that is just with a simple hook load threshold. You could actually set up your own slip channel here by using hook load and just saying, well, whenever the hook load drops below this value, I know that I must be in slips, because I couldn't have a hook load that low unless I was making a connection. So I've identified the period of time where I'm making a connection. Now the next step, and this is all in sequential order, I'm going to pull data out of undefined and I'm going to put it into rotary drilling. And how I'm going to do that is by looking at the ROP channel. And whenever my ROP is greater than 1, I'm going to call that rotary drilling. Now, it's not actually all rotary drilling, because sometimes I'm logging ROP, but I'm slide drilling. And so now the next step of the sequence is I'm going to take data out of rotary drilling and I'm going to put it into slide drilling if my surface RPM happens to be less than 40. Now you might say, well, shouldn't it be if my surface RPM is 0? If I have ROP and my RPM is 0, then it must mean I'm slide drilling. Yes and no. When we're using a rocking system, the rig is going to register a positive RPM, 10 RPM, 20 RPM, 30 RPM, even though we're not rotary drilling, because the top drive is turning and then it's going in reverse, and it's turning and going in reverse. So we do need to kind of filter that out and put it in the more appropriate category, which is slide drilling. Anyway, if you study the binning rules, you'll kind of understand the logic and the sequence that we're going through. The cleanup rules that I talked about. So you'll notice anytime that we're pulling data out of a categorized bin, let's say pickup. If I'm pulling data, if the source bin is pickup and I'm putting it back into undefined, well, that is because I'm using this criteria called normalized length of motion. Normalized length of motion basically looks at the distance that the blocks have moved since the bin started, and it looks at that distance moved relative to the overall length of the drill string. And what we're expecting the rig to do is overcome a certain amount of stretch in the string before it actually considers that picking up, so that we don't get bad pickup measurements, if you will. So normalized length of motion is one way that we kind of clean up our pickup data so that it actually fits the hook load plots better. Block acceleration, that's another way that we clean up data. RPMs, we don't want to be taking in drilling mode any pickup measurements with the rotary on. So we're going to say, hey, if I'm rotating more than 10 RPM, don't count that. So on and so forth. That's how we clean up the data. Other ways that we can clean up data is with what we call thresholds. Thresholds is how we overcome certain data channels that log a small value even if we're not using that piece of equipment. For example, flow rate. Perhaps the pump stroke counter is logging 1 or 2 strokes per minute, even though the pumps aren't actually running. I can clean up that data and treat that flow rate as if it's actually 0 by setting a kind of a minimum value or a threshold. What ERA is going to do is anytime that I've got flow rate that is below 50 GPM, it's going to say, well, essentially you're not pumping. So I'm going to call that 0. And you may choose to turn that off if you don't think that's a good rule, or you may want to manipulate the values. You as the user have full power and authority to do that. Ideally, what we hope to do is evolve these rules so that the users don't really have to manipulate them too much. But you've got a lot of flexibility here if you feel like you've got an idea for a filtering routine that might give you a better process. You can even manually process the data. In the manual here, you can say, well, whenever I click on this plot, if I say that I'm going to click on the plot and everything's going to go to undefined, if I just click from here to here, what ERA will do is override anything else that you've done, and it will put that period of time into whatever bin you want to send it to. Maybe you say that it's all picking up or it's all slacking off. You've got quite a bit of control there. Now, that's not actually what's going on, so I'm going to delete that and just say, no, that wasn't quite such a good idea. And then ERA will go back to the way that it was before without that manual rule. So a lot of power and control. The whole point of this, why we're going through this whole process, is not just for the sake of putting things in categories, but to come back on over here to our drilling and hopefully populating our plots now. All this data came directly out of time. We didn't have to manually enter it, and I'm now overlaying data on top of my theoretical pickup and slack off, on top of my theoretical torque, And I've also got some real good on-bottom calculations going on now as well. You can see my theoretical pump pressure versus actual pump pressure. I'm able to now start calculating and processing mechanical specific energy. I've got downhole calculated MSE now, and that's overlaid on top of my confined compressive strength there in pink. Uh, lots of neat stuff that you can do, and you can do it with very little effort once you bring that data in and process it within time-based data. So I hope you enjoyed this video. Hope it was useful for you. If you would like more information, you can always email us at kmtsupport@kmtechnology.com.